Hello, students, and welcome to the second lesson in our unit on logical reasoning. In this lesson, we're going to unpack the second topic, which is about symbolical logic, okay? We're going to be talking about the symbols that are used in a logical argument. All right, well, I have a list here at the very beginning of all the symbols we're going to be responsible for, 6 different things. 2 of them we've already introduced in an earlier lesson. This first symbol, I'm really focused on the arrow here. This symbol represents an if-then statement. That's known as a conditional statement. This would translate to if whatever the topic about P is, then whatever the topic about Q is. That's called a conditional statement. The double-sided arrow listed second here is a very special kind of conditional statement. It's a statement that can be read both forwards and backwards and still be true. That's known as a biconditional statement. This arrow has its own special translation. We would start with the P concept, use the phrase if and only if to connect it to the Q concept. That's a biconditional statement. We saw one of these statements in our last lesson. The statement we used, I'll bring this over from our last lesson. The statement we used was about right angles here in the middle. The conditional is, if an angle is right, then it has a measure of 90 degrees. The converse of that statement would read, if an angle measures 90 degrees, then it is right. Well, both of those statements are true, so we could squish them together to build the biconditional. An angle is right if and only if it measures 90 degrees. There's that phrase that detects a biconditional, if and only if. So these 2 symbols we've already seen. Let's talk about this next symbol. We've seen it also. This little squiggle has 2 jobs in geometry. One of the jobs is to represent similarity of triangles or other figures. We are now using it to represent a negation of a statement. It translates to the word not. I like to put that not in capital letters. That way I know that it's making a real impact on the statement. That's considered a negation. There are other ways to negate a statement that may fit into the grammar of the statement better, but not is a really good way to change the truth value of a statement. Our next 3 symbols are new for us this year. This first one that looks like an A without the line in it is the symbol for the word and. We're going to be using and as a conjunction statement. I could break out in song right now, but I won't. See if anybody gets that. And is used to combine 2 different statements. I like peanut butter and I like jelly. That means you like both of them. This second symbol in the pair, it sort of looks like a V. It translates to the word or. Now maybe back from your days in algebra, you know what's coming next. An or is considered a disjunction. An or statement allows you to like either or of the topics being described. I like peanut butter or I like jelly. You only have to like one of them for the entire statement to be valid. We'll get into that a little more later. Finally, our last symbol here is a set of 3 dots in the shape of a triangle. This translates to the word therefore. This is going to signal your final conclusion or your final answer to a problem. This will be the end result. Okay, so let's see if we can start using these symbols in various examples here. Our directions say, translate the following by using the logic symbols. First, let P represent the phrase, I love geometry. Then let Q represent the phrase, Miss Denton is my teacher. So here's the argument. If Miss Denton is my teacher, then I love geometry. Giving myself a little pat on the back here. Well, Miss Denton is my teacher. I've got some colors here to help me organize this. Miss Denton is my teacher is the Q phrase. I love geometry is the P phrase. The only other things in this sentence are an if-then. So, going up here to my list of options, I know an if-then comes from the conditional statement symbol of a right arrow. So, if Miss Denton is my teacher, that's Q. Then, I love geometry, which is represented by the letter P. This is a translation that matches the statement. Let's try again. This time, talking about something very near and dear to our hearts. Let P represent today is April 14th. Let Q represent it's the first day of spring break. The argument that we're translating is today is April 14th and it's the first day of spring break. Okay, pull my highlighters back out here. This first statement, today is April 14th, is represented by the letter P. The second statement in the back, it is the first day of spring break, is represented by the letter Q. The word that connects this compound sentence is the word and. This is referring to the conjunction of 2 topics. We use the up-facing arrow symbol. P, up caret, Q is a symbolic representation of this statement. One more to go here. My final example includes this P and Q statement. P, an equation is of the form y equals mx plus b. Q, its graph is a line. Rolling it back to algebra years. So here's my argument. It's a rather long argument this time. An equation is of the form y equals mx plus b if and only if its graph is a line. The graph is not a line. Therefore, the equation is not of the form y equals mx plus b. Let's start breaking it down. Here we go. Sentence number 1. An equation is of the form y equals mx plus b. That is the P statement. I'm going to start with P. Oh, I see that very important phrase, if and only if. That is a very special phrase that signifies a biconditional statement. The symbol for a biconditional statement is the double-headed arrow. The statement finishes with, its graph is a line. That's the Q statement. For the second statement here, we have the graph is not a line. So we're taking the Q statement and negating it. Finally, we finish with the word therefore, And we finish the statement saying the equation is not of the form